Welcome to Math Unit 2. Now that you have a handle on dimensional analysis, we're going to step up our game. In nursing, we use 3 systems of measurement. Certainly we use one of them more than the other 2 combined, but you do need to be aware of all 3 of them. We're going to spend most of our time talking about metric, but apothecary and household is something we do need to learn. This week, in this lesson, you will be converting within systems, not between them. So you're going to learn how to go from metric to metric, apothecary to apothecary, and household to household. As I said, we will be working with 3 different systems of measurement: metric, apothecary, and household. Metric most of all, but the other 2 still play a part. In order to give you enough practice problems across all 3 systems, there are actually 2 math quizzes, practice quizzes, in your math book for this week, and those practice quizzes are on page 5 and 6. I think 5 is the apothecary household one, and then 6 is the metric. So we'll start with a brief overview of the 3 systems of measurement. The metric system is the one we're going to use most often. It's extremely accurate. So clearly when you're giving patients medications, we generally try to be as accurate as possible. It was developed in the late 18th century, and it is the internationally accepted system of measure. That's why when you're watching the Olympics or some other type of international sport, if they're talking distances, they're not going to talk in miles or even feet or even inches. They're going to talk in kilometers or meters or centimeters. That's something that you'll have to get used to. Living in this country, we think in feet, inches, miles. We think also in pounds and ounces, whereas in this metric system, you have to learn grams and kilograms, but more on that in a minute. The apothecary system dates back to the Middle Ages, and this is kind of represents the first time when people who were actually called apothecaries came up with different remedies for illnesses, and they tried to dispense them in a way that was, somewhat consistent. They didn't have superbly accurate ways of doing it, but it's reasonably accurate. And we will talk about that and where some of the discrepancies lie. Household, these are very commonly used in community and home settings. These are probably the least accurate of all, but everybody's done this. You've read on a bottle, it says take a tablespoon of cough syrup, and you just opened the silverware drawer and popped out a tablespoon and filled it up, and then you took that as your dosing. So is that going to be exactly the same every time you do it? Probably not, but that one is also something that's done very commonly. The metric system is composed of units of measure for length, volume, and weight. Now, in the medical profession, we use volume and weight most often. Length we use here and there, but it's just not used nearly as often as the other 2. Even though the metric system gives us those 3 units of measure, they're not in and of themselves universal. You can't use a meter, which is about the length of a yard, to measure everything. I wouldn't want to measure the distance from here to, say, Indianapolis using a yardstick, but that yardstick would be too big to measure a wound on a patient's leg. So we need to modify that unit. We need to have multiples of that unit that we can use to measure larger distances, and we need to have much smaller fractions of that unit that we can use to measure smaller things. So the metric system provides that for us. We can modify the unit using a prefix that tells us whether it is a multiple or a fraction. Now, in all honesty, we don't use deca and hecto very often, but they are 10 times the unit, 100 times the unit. But now kilo, we do use that one, especially when we're talking about grams, because we use kilograms quite often. But kilo is 1,000 of whatever that unit is. So if it's kilometers, it's 1,000 meters. That's 1 kilometer. If it's grams, 1,000 grams equals a kilogram. But then there's also fractions of the unit. These you're going to see a lot more, and especially you will see centi reasonably, frequently when you're doing, say, measuring wounds and things like that. But milli we use a lot. So deci is 1/10 of a unit. Centi is 1/100th, and milli is 1/1000th. And anytime you are dealing with a fraction of a unit, meaning something that is less than 1, and you're turning that into a decimal, you always put a 0 in front of that decimal. That is done to draw attention to the decimal so that you don't have an egregious overdose of some way. If you just put 0.5 on a piece of paper and your decimal point doesn't get seen, that person might actually give 5 instead of 0.5. That would be a 10-fold overdose, and obviously could be very, very dangerous for a patient. So you always have to put a 0 in front of the decimal point. Get used to that right now. In fact, after the first week, if you forget to put a 0 in front of the decimal point, you're going to get that problem wrong, even if you did the math right. That's how important it is. So we'll start with length. Meters are linear measures. They are way too big to be used for height. I wouldn't even want to know what my height would be in meters. That would be very depressing. So we usually measure height in centimeters. We also measure any other linear distance. Like I said, the length of a wound or the depth of a wound would be measured in centimeters. Okay, centi is 1/100th of that meter. Roughly 1 centimeter is about 2/5 of an inch. The actual conversion is that 1 inch equals 2.54 centimeters. Don't worry about writing that one down, but it kind of gives you an idea of where you're at. So if you look on your person and you're trying to conceptualize what a centimeter is, look at your pinky finger and look at the width of it. The width of your pinky finger is roughly a centimeter, okay? 1 foot, which we all know is 12 inches, and we're like, yeah, we get that, that's in our head, but it's hard to conceptualize that in centimeters, so I'm just trying to give you some approximations. You do not need to memorize any of the measurements on this particular slide. I'm just trying to give you something to base it on. Excuse me. 1 foot is about 30.5 centimeters, and a 6-foot tall person is going to be roughly 183 centimeters. So next we'll talk about liters, and liters are the liquid volume measurements. However, they're way too big for medication administration. Think about a 2-liter bottle of soda. Would you want to take half of that anytime you needed to take a medication? So what we do is we take that liter and we take a fraction of it, meaning 1,000th of it, and we call it a milliliter. Most of the time when we're administering something, we're giving it in milliliters. So whether you're taking it orally or it's being injected into that person, milliliters is going to be what you see most common. However, there's older terminology for that. Before we used milliliter, we also had another way to measure that, and it's a cubic centimeter. So if you take a centimeter and you have a cube that's 1 centimeter wide, 1 centimeter tall, 1 centimeter in depth, that would be a milliliter of fluid. Cubic centimeters is abbreviated cc. So a milliliter equals a cc. They are the same thing. They are interchangeable. 1,000 milliliters equals a liter. 1,000 cc's also equals a liter. Here are a couple of conversions for you to practice with. Now, what would be really great is if you stopped the video right now and you actually worked those and made sure that you knew what they were before you go on to the next slide. All right, the last unit of measure for metric is weight, and we use grams for that. But in a lot of cases, grams are really not the right measure. We need to modify it. Grams are way too small to measure the weight of an adult. Why? Because a gram is roughly the weight of a paper clip, one of the larger ones, not the smaller ones, but still, how many paper clips do you weigh? Do you really want to know that number? I don't. So we use kilograms instead. 1 kilogram is 1,000 grams. Another way to say that would be 1 gram is 1/1000th of a kilogram. But we also sometimes need to convert, whether it's just in our own brain so we can understand a weight, or whether it's for medication dosage, and we will be doing that, we have to understand that 1 kilogram equals 2.2 pounds. And that is a conversion on this slide that you definitely need to add to your repertoire, okay? Because you will be using that quite a bit. If your patient's weight is given to you in pounds, because, well, either that's the way they were weighed or they just know how much they weigh in pounds and not necessarily in kilograms, you may have to convert that to kilograms for drug dose calculation. So this 1 kilogram equals 2.2 pounds is going to be a very important conversion for you to learn. On the other hand, grams can be used in medication administration, but most of the time it is way too big. Very few medications, there are some, but very few medications can be measured out in grams. Most of them are measured out in milligrams. Okay, and I'm going to talk about that momentarily. But both G, a lowercase g, or GM are the appropriate abbreviations for gram, and you will see those used interchangeably. Now, as I said, grams are usually too big for most medications. If you just look at the normal dose of most medications, they're in milligrams. So 1 gram equals 1,000 milligrams. So let's put that in perspective. Remember that paper clip? If you divide that paper clip into 1,000 pieces, that's a milligram, okay? So if you're taking 10 milligrams of something, you're only taking 10 of those tiny little pieces, and that's the dosage for that medication. Milligrams are the most frequently used in drug dose calculation. However, sometimes they are still too large. So we use something called micrograms. Wait, wrap your head around this, okay? So that 1 milligram, that 1/1000th piece of that paperclip, if you divide that into 1,000, that's a microgram. So a microgram is actually 1/1,000,000th of the paperclip, or 1/1,000,000th of a gram. We use two different abbreviations for micrograms. The one that's obviously easier to write and understand is MCG, microgram, but you will also see that other wonderful little symbol there. It looks like a funky U with a tail on the front for micro. That is a valid abbreviation for microgram, and while I do not expect you to write it, you can just write MCG. You do need to be able to recognize it and know what it is and be able to, do your drug dose calculation based off of that. So on the next slide, I'm going to give you kind of a summary of these gram measurements for the metric system that we're going to use in drug dose calculation. So here is your summary, and I like to start at the bottom and go to the top. So if you have 1,000 micrograms, that's going to equal a milligram. If you have 1,000 milligrams, that's going to equal a gram. If you have 1,000 grams, that's going to equal a kilogram. If you like doing it the other way and saying 1 kilogram's 1,000 grams, 1 gram's 1,000 milligrams, 1 milligram's 1,000 micrograms, I don't care. Do it however it makes sense in your head and however it stays there. But also don't forget the one other conversion I told you about so far in this, which was the 1 kilogram equals 2.2 pounds. I know I said we're not converting between systems so much yet, but I have that on there so you start getting an idea of what a kilogram actually is when you're conceptualizing it. So this slide is going to sum up what we've done with the metric system so far. There are 4 conversions on here that you will need to do. I would stop the video right now and try to do them on your own before you go on to the next slide, because on the next slide I'm going to go over each one of them. So stop the video, and then once you have it done, restart it. So our next system of measurement is the apothecary system. This one only uses measures of weight and volume, nothing linear, okay? And it's also got a little bit of weirdness attached to it, so I'm going to tell you that right up front. What I mentioned before was when apothecaries were trying to be consistent in the way that they dispensed or administered medication to people, they tried to find a constant, something that they could use to weigh against, because they didn't have instruments that could do that weighing. They literally used a scale and put one thing on one side of the scale and put the medicine on the other side, and they wanted it to equal out. So the smallest unit of weight measurement that they could come up with was millet grain. Now these things were itty bitty teeny tiny, literally called a grain. So if the apothecary needed 5 grains of medication for a patient, they would literally take the grain that they had from a grain sack and put 5 pieces of grain on that scale, and on the other side put the medication powder. This is where kind of comes back to taking a powder, putting that powder on the other side until they equaled out. But I have to ask you, is every single piece of grain identical? No, they're not. There's going to be slight differences. So there would be slight differences, but it wouldn't be, big differences. That's the smallest unit of weight. The smallest unit of volume is something called a minim. Now, you're not going to see this very often, but here's what will freak students out. On syringes, sometimes they will have cc's or milliliters on one side, and then as you rotate the syringe on the other side, it'll have minims on there. And then students, sometimes they get confused and they're trying to draw up on the minim scale when they really should be drawing up on the milliliter scale. So I'm not going to have you learn a whole lot about minims. You'll have to learn one conversion with minims. But do you see that ridiculous symbol with the M with the little tail and it looks all weird? Yeah, that's the symbol for minim. So don't try to draw it, just remember it. So grain is GR, and I know there's lots of G's. We've got G for gram, and we've got GM for gram. We've also got MG and MCG. Well, now we get to add GR to our mix. So grain is GR, minim is that weird little M, or you can just write out the word minim. The next one for both of them, for weight and volume, you go up, is called a dram, okay? It is, where they got this from is a Greek coin was called a drachma, and they would, instead of using the millet grain, they would use this Greek coin, and that was what they called a dram. So they would put the coin on one side and they would put the medication on the other side until it equaled the weight of that coin. But again, is every single coin minted exactly alike? No, but they were still pretty close. And then last but not least, we have ounces. Now, we generally abbreviate ounces as OZ, but do you see that weird number 3 with like a top hat? That's the symbol for ounce. And no, I'm not making this up. You can Google that. It's super fun. But basically the way it works out is 60 grains equals a dram, 60 minims equals a dram, but 8 drams equals an ounce. And people always say, well, are grains and minims the same thing then? Well, they're different because they're different measures. One is measuring weight and the other one is measuring volume. And so you can't just say they're equivalent because they're not measuring the same thing. Hopefully that makes sense to you. All right, before I give you the summary slide for apothecary, there's a couple of pieces of weirdness that I need to acquaint you with. In the apothecary system, most of the time when you see it written out, you're going to see that the unit actually precedes the number. So in metric, we write 10 milligrams, 10, and then mg following it. But with apothecary, instead of it being like 1/4 of a grain, it's actually going to be written grains 1/4 or grains 10 instead of 10 grains. It's just a little bit of weirdness, but you've got to be able to recognize that. Numbers below 40 in the apothecary system are also usually expressed in Roman numerals, okay? So you'll see I's for 1, V's are 5s, X's are 10s. So instead of seeing grains 3 written in an Arabic number, you're going to see it written as GR and then 3 little I's behind it because that stands for 3, okay? Do I expect you to write Roman numerals? Good grief, no. But you've got to be able to read them, to see them and understand what they mean. There's also a really weird symbol for 1/2. The symbol for 1/2 in the apothecary system are the letters SS with a line over the top. Okay, I can't make the PowerPoint put a line over that SS. but it would be an SS with a line over it. So you might see what is supposed to be 7.5 grains written as GR for grains, VII, that's 7, and then SS with a line over it. So grains, 7.5. Super fun, right? Practice that a little bit if you are, rusty with Roman numerals. There are some things on Google where you can go in and just do a little practice thing, but you're only doing numbers 1 to 40. You don't have to worry about anything above 40 because those were expressed in Arabic numbers anyway. Okay, here's your summary slide for the apothecary system. Whether it's weight or volume, you're going to be using drams and ounces. The one thing that changes is the smallest unit of measurement. So with weight, it's grains. With volume, it's minims. But the conversions are still the same. 60 grains equals a dram of weight, and 8 drams of weight equals 1 ounce. Whereas 60 minims equals a dram, and that's volume, and then 8 drams equals an ounce. So the 8 drams always equals an ounce, whether it's weight or volume, but it's whether it's 60 grains or 60 minims, that's the difference on what's going to equal a dram. All right, our last system of measurement is household, and this is for liquid meds only. And as we mentioned before, it's not very accurate. Using a tablespoon or a teaspoon out of your silverware drawer is not going to be an extraordinarily accurate measurement, but it will get you in the ballpark. The most common unit of measurement is going to be the drop, and that's if you've got a medicine dropper. It's abbreviated GTT, and you'll see that on a future abbreviations page coming up soon. But drops are probably more accurate, but even those aren't great because it depends on, does any air get mixed in with it? If you squeeze it slower, the drops tend to be bigger. If you squeeze it faster, sometimes the drops are smaller. They're hard to count. So it's still not extremely accurate. I've got some conversions on here for you though, and that is 60 drops equals a teaspoon. So you can understand why at some point you just want to say, let's do a teaspoon of it, because who wants to count 60 drops of anything? 3 teaspoons equals a tablespoon, and then 2 tablespoons equals an ounce. So you really just have those 3 conversions that we're going to make you learn for household right now. 60 drops equals a teaspoon, 3 teaspoons equals a tablespoon, and then 2 tablespoons equals 1 ounce. And then I've got some problems coming up for you on the next slide. All right, so here's our last batch of problems, and I've mixed in some apothecary and household. Stop the video, take a couple of minutes, and try to work these before you go on to the next slide and I go through the answers for everything.